All right, here are solutions for quiz 4, I guess, for Math 213. You're supposed to look at this picture here, and you see a triangle, and you're asked what percentage, I think. Is that what it says? How about you tell me what percentage of the triangle below is shaded in green? Okay, so what I first want to do is I want to figure out the area of the triangle. And then I want to figure out the area of the shaded region. I'll write this in green. And if I know those two things, then I could divide them to figure out my answer. And so to figure out the area of a triangle, you'll note that there aren't any units here. So you kind of have some freedom in terms of what you do. I will let 1 unit be the radius of the circle. You might choose to let it be something different, but what I'm going to do is say the distance from right here to right here is exactly 1, that radius of the circle right there. Well, since the circles are all the same size, then what that means is the distance from here to here is also 1. And the distance from here to here is 1, and the distance from here to here is 1, and 1, and 1. Okay, so if I'm trying to figure out the area of the triangle, I know that the area of a triangle is 1/2 the base times the height, which is 1/2 times 2 times the height, because the base here is exactly 2. And to figure out the height, what I can do is kind of draw it in here. Be like, well, the length of that red line right there is the height, but note that I have a right triangle here. So using Pythagorean's theorem, I know that a squared plus b squared has to equal c squared. So playing the role of a in this case would be 1. And playing the role of c would be 2. So what I get is that b squared, maybe 1 plus b squared equals 4. So b squared equals 3. So b is equal to the square root of 3. Technically, it's plus or minus the square root of 3, but since we're talking about length, we're talking about a positive distance here. I got b as the square root of 3. So I can plug that in over here and get that my area is 1/2 times 2 times the square root of 3, which is just the square root of 3. So I have the area of this triangle right here. What I want to know is what the area of this shaded region is. Well, that's a strange little area there. We certainly didn't learn a formula for the area of that region. But the area of the shaded region I could figure out is it's everything that's not in blue here. And I think I can figure out the area of these blue segments. So let's see, let's first find area shaded in blue. Well, it looks like I have, if this is an equilateral triangle, that means that this is 60 degrees. So I have 60 degrees worth of the circle here, and another 60 degrees worth of the circle here, and another 60 degrees worth of the circle here. I have each circle has exactly 1/6 shaded, and that's because the angle is 60 degrees because it's equilateral. So 3 circles, each with 1/6 shaded gives 3/6 of a circle that's shaded. So 3/6 is the same as 1/2. So I have maybe shaded total shaded in blue equals half of the area of a circle. The area of a circle is pi times the radius squared, which is just half of pi. So in blue I have this much shaded. I know that the entire triangle is the square root of 3. So let's see, shaded in green, is the square root of 3 minus 1/2 pi. And so the percent shaded is this amount that's shaded in green, square root of 3 minus 1/2 pi, divided by the area of the triangle, which we said was the square root of 3. So whatever this number ends up being, maybe I'll pull out a calculator. Into a calculator, and I got approximately 0.093 or 9.3%. Pretty hard problem. I'll probably have to throw a couple more hints in here to make this doable, but I think that's the answer you'll end up with. Then you move on to part 2, and I said that in part 2 I couldn't really come up with anything creative, so really you're just going to recreate that worksheet for me, which is probably welcome after how hard part 1 was. So what you did on that worksheet is you kind of started out with a circle, guess that's a circle, and you split it into 8 pieces. So 1, 2, 3, 4, 5, 6, 7, 8. And then you rearrange those 8 regions so that they looked like a trapezoid. So you kind of have one here, and then you have one here, and one like that, one like that, and one like this. Maybe I should number these. So 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to rearrange those so they kind of look like this. I need 3 more, so I can kind of draw one here, and then draw one there, and then draw one there. 6, 7, 8. And this thing kind of looks like a trapezoid. And then you can figure out the area of this trapezoid. You can say the area of a trapezoid is 1/2 B1 plus B2 times H. But if you look up here, B1 is 1/8, or how about this? Let's figure out the circumference of this circle first. It says, hint, the circumference of a circle is 2 times pi times the radius. So my radius is r, so my circumference will be 2 times pi. You know what? Instead of the radius is r, let's make the radius 1. Let's make your life a little bit easier. So the circumference is 2 times pi. And so if all the way around the circle is 2 times pi, then B1 is 1/8 of 2 times pi, aka pi over 4. And B2 is 3/8, 1, 2, 3 of the way around the circle. So it's 3/8 of 2 pi, which is equal to 6 pi over 8, aka 3 pi over 4. So then you come over here, oh, and we still need to know what h is equal to. Well, h is kind of this height here, which is 2 of my radius. But since my radius is 1, the height is just equal to 2. So then I take this formula. Oh man, I guess I better not get rid of the r in this thing. Okay, the circumference is 2 times pi times r, because I want your formula to work out. So we'll leave that as an r up there. And what that means is this is 1/8 of 2 pi r, in other words, pi over 4 times r. And this is 3/8 of 2 pi r, which is 3 pi over 4 times r. And the height is 2 times the radius, which is just 2 times the radius. So then you come down here and you plug all those things in. You get 1/2 pi over 4 times r plus 3 pi over 4 times r times the height, which is 2 times r. And so what ends up happening is pi over 4 plus 3 pi over 4 is 4 pi over 4, aka pi. So you got pi times r times 2r. The 1/2 the 2 gives me a 1, and so I get pi r squared. which was the area that I was hoping to prove. So what I just showed is that the area of a circle is equal to 2 pi r by taking this and kind of putting it into a trapezoid. And you're like, yeah, but that's not a perfect trapezoid. You have these weird curved parts here. True, but if I cut it into more than 8 pieces, I'd get closer and closer to a real trapezoid. And this formula would get closer and closer to exact. So I guess I'll call that good here.